All right, today we're going to do lesson 6.3, and we're going to learn about exponential functions. Now, so far, the only functions we've really dealt with are linear functions. What can you tell me? Somebody raise your hand. What can you tell me about the graph of a linear function? What's it look like? The graph of a linear function. It's a line, okay? And all 21 of you should have raised your hand in the air to tell me that, okay? Together, tell me, the linear function has a graph that is a what? It is a what? Okay, it is my job. The first day you walk into Mr. Cosen's class, I'm pretty sure lesson 1.1, you're supposed to be able to show that you can identify linear functions, quadratic functions, and exponential functions. So, that is what I'm trying to teach you. Exponential functions is what we're going to learn today. And we'll look at in a little bit when we graph them, we'll look at their shape and how they are different from linear functions. But our essential question for today is, what are some of the characteristics of the graph of exponential functions? So, an exponential function is a non-linear function. That's the first thing. Okay, if you graph an exponential function and have a line, you have done something wrong. Okay, it's a non-linear function. The form of an exponential function, just like for linear, we used y equals mx plus b a lot. Okay, for an exponential function, you have the little formula y equals a b to the x power. Now, I want you to highlight that formula. Okay, if you've got your highlighter, somebody at your desk does, you can borrow. But that is the formula for an exponential function. Now, look at the stipulations. A cannot equal 0, ever. B cannot equal 1. And b is going to be greater than 0. Now, we know 1 is greater than 0. So that's why we got to remember b can't be 1. But what else will b never be if b is supposed to be greater than 0? What does that mean the letter b will never be? Okay, I love that I'm getting all these answers. Okay, that's good. But think about it a little bit harder for me. If b has to be greater than 0, what numbers are not ever greater than 0? Negative. Very good. Negative numbers. Okay, so b is always going to be greater than 0, except it won't be 1, which means it's never going to be negative. All right. Now, as x changes by a constant amount, and we've done this before, when we were looking at tables trying to figure out if they were linear functions or not, we had to look for a pattern on the y. Okay, we found a pattern on the x. As x changes by a constant amount, okay, for a exponential function, the y values are going to be multiplied by a constant factor. Now, with linear functions, they were either added or subtracted by a constant amount. But exponential is different because it's going to be, your y values are going to be multiplied by a constant factor. And we'll practice that here in just a few minutes. All right, example number 1. This is simple. Evaluate the function when x equals -2, 0, and 1/2. So what are we going to have to create? We have x values, we got to plug them into a function, and we got to see what y equals. So what are we going to create to do this? What kind of a chart? An x and y chart. All right, very good. So we've got x, and they've told us -2, 0, and 1/2. We know that our function is y equals 2 times 9 raised to the power of x. And of course, once we plug this in and work it out, we're going to end up with our y values. Now, let's plug those values in. Y equals 2 times 9 raised to the -2 power. Y equals 2 times 9 raised to the power of 0. And y equals 2 times 9 raised to the 1/2 power. Now get your calculators out. And let's think about the order of operations. The order of operations, please excuse my dear Aunt Sally, says that I have to do what first in this function? Okay, not in this function though. Parentheses is always first, but there's no work to do in the parentheses. So we've got an exponent and we've got multiplication. Which one are we supposed to do first? Exponent. So in your calculator, you're able to take 9 and raise it to a -2. And then multiply it by 2. Somebody raise your hand and tell me what you get. 2 over 81. Okay, remember, we don't do decimal answers unless our problem starts with decimals in it. So 2 over 81 is perfect. Now, the next one doesn't really need a calculator because, Layla, what is 9 raised to the power of 0? No. Anything to the power of 0 equals 1. And 2 times 1 is, everybody, what's 2 times 1? 2. So our second y value is 2. Now we're going to put 9 and raise it to the power of 1/2. We learned how to do that in our calculators a couple days ago. And we're going to multiply it by 2. And what? Somebody raise your hand and tell me, what do you get? 6 is the answer. Very good. So box in the entire chart and you're finished. Now go ahead and work with the people at your table and do letter B. Now, what does this function have in it? What kind of a number does it have in it? Decimals. So guess what I want your answers to be? Decimals. All right, we plug in 2 and we raise it to the power of -2. And then we multiply it by 1 5/10. And what do we get? 0.375. So normally I'd tell you to round to 2 decimal places, but that's when we get a really long, crazy decimal. In this case, that is the answer. So just put the whole answer, 0.375. Now, what's 2 to the power of 0 equal, class? 1. And what's 1 times 1.5? 1.5 or 1 5/10, if we read it correctly. All right, and then we take 2, we raise it to the power of 1/2. We multiply it by 1 5/10, and we get a really long decimal. So let's round to 2 decimal places. Blake, what do you get when you round it to 2 decimal places? 2.12. Awesome. And there is your X and Y chart. Box it in and you are finished. Okay, any questions? Awesome. Now, here's your tables. So does the table represent a linear or an exponential function? Now, you have done this before. You have figured out the pattern on X and you have figured out the pattern on Y for a linear function. But how do you figure out if it's not linear that it's exponential? All right, so that's what I'm going to show you. First of all, let's check X and let's just make sure X is increasing by the same amount all the way across. So Tristan, how do I get from 0 to 1? And from 1 to 2, add what? All right, let's check. Let's just make sure. She says we're adding 1. 0 plus 1 is 1. 1 plus 1 is 2. And 2 plus 1 is 3. All right, good. Now, we're going to check and we're going to see if this is linear. So what do you think they're doing? If it's linear, how are they getting, or how did they get from 8 to 4? Okay. Now, for those of you that aren't quite sure how to do that, I've given you up here in the notes, I've given you this little bitty tip. Subtract the second term from the first term. Remember arithmetic sequence? We learned how to do that. So 4 minus 8 would give me a -4. So let's check and let's see if they, all the way across this table, if they have subtracted 4. So what is 8 minus 4? 4. And what is 4 minus 4?
0.
So is that what they've done all the way across the table? No. So is this linear? No. So let's erase that. And let's cross this out because we know it's not linear, so we're just going to cross it out right here. So let's check and see if it's exponential. Now, how do we do this? We're going to take the second term and divide it by the first term. So for exponential, we take the second term of 4, we divide it by 8, and what does that equal? 1/2. Now remember, we talked about at the beginning of the lesson, an exponential function, the pattern is to multiply by the same factor all the way across. So we're going to check and see, are they multiplying by 1/2 all the way across? So let's write it down. Okay, we're showing our work. Let's see if they've multiplied all the way across by 1/2. What is 8 times 1/2?
4.
What's 4 times 1/2?
2.
And what's 2 times 1/2?
1.
So does the pattern work? Yes. So guess what? My problem is exponential. I box in exponential. And when it says explain, I'm good with the work. If you've shown me the work, I'll take that as your explanation. You've shown me that you multiplied all the way across the table by 1/2. So show me work, That's your explanation. Decide not to show me work, and then you're going to have to use a sentence to explain it to me. All right. Now, letter B. Let's check X. Let's just see what are they doing to the X values all the way across. Okay. I heard add 4, so let's just check and make sure. -4 plus 4 is 0. 0 plus 4 is 4. And 4 plus 4 is 8. So X is increasing by 4 every time. Let's see what Y is doing. All right, let's check to see if it's linear. Now, sometimes it's just going to be super obvious. Okay, how did they get from 1 to 0? Be careful. They subtracted 1. So let's check it all the way across. What is 1 minus 1? Okay, what's 0 minus 1?
-1.
And what is -1 minus 1?
-2.
So is it linear?
Yes.
Yes, it is. Box in linear. And again, the work is your explanation. You showed me that you subtracted 1 all the way across. So that is how you figured out it was linear. Now again, let's look at these two. Okay, because you're going to see this. This is something like this is going to show up in 6-4 tonight. So I want to make sure you understand. Okay, if it's exponential, it's being multiplied by the same factor all the way across. If it is linear, it is being added or subtracted by the same number all the way across. So please know the difference. All right, now we're going to our graph. So go ahead and grab your phones and open up Desmos. Okay, only Desmos should be opened on your phone. Now, I'm going to change it up a little bit when you copy your graph from Desmos onto your graph paper. If you can give me 2 points, that will be plenty for this exponential function, okay? Find 2 points. One of those points is always going to be your y-intercept, all right, your y-intercept. But the other point, just find me one more point at least, and that will be sufficient, all right? Now, let me teach you about Desmos because you haven't done this before, I don't believe, where you've had an exponent. So you're putting, what's the same variable as f of x? Y. So y equals -2, then you insert your parenthesis, put your 4, close your parenthesis, and you see the button that's a raised to the power of b? You hit that button because that allows you to make the exponent whatever you want. If you hit the a squared button, it's just going to square it, and you don't want to square it. So see that a to the power of b button, hit that, and then you can hit the x because you want your exponent to be x. Now, let's talk about the shape of these graphs. Okay, this graph right here. Somebody raise your hand and describe for me what it looks like, because it shouldn't be a straight line, right? Those are linear functions. This is exponential. All right, what's it look like? It curves. Okay, it curves. To me, some people might say it looks like to me, it looks kind of like a boomerang, if you will, you know. But it definitely is not a straight line. All right, but you got to be careful. So give me, Caleb, give me the give me the y-intercept. When you're looking at Desmos, where does it cross the y-axis? Hold on, I asked Caleb. At -2. So right here, we're going to put our point at -2, all right, on the y-axis. And then I need one more point. Luke, can you give me one more point? Everybody should be on Desmos really looking at this, not waiting to hear the answer. You should be looking at it for yourself. Okay, give me another point on that graph. Okay, but I need an ordered pair. So it would be 1 what?
I think I put it in wrong.
Yeah, you don't have the -2 on the outside. Okay, Layla, can you give me another point?
0, -2.
I already got that. That's the y-intercept right here. I need one more point anywhere along the graph. Does anybody have one? All right, Nate.
-3,
All right. No, because this graph is not actually cross the x-axis. It runs along it. If you zoom in really close, you're going to see it runs along. Maybe even lays on top, but it doesn't cross it. Okay, you got another one?
4, 0.
But you're still putting me on the x-axis. Find something along the line. Don't give me along the x-axis. All right, I got a 1, -8. So right 1 and down to -8. That's perfect. Now, notice what this graph does. When this graph curves, and this is exponential functions, when this graph curves, it's going to run along a horizontal line. Now, horizontal lines cut through which axis? X or Y?
Y.
Okay, so does everybody know that or just one person? Horizontal lines, everybody, they cross through what axis?
Y.
Okay, the Y-axis. So these lines are going to, when they curve, they're going to run along a Y value. They're not going to actually cross over, they're going to run. And in this particular problem, it's running along the X-axis. So you need to draw, be very careful. Make sure as you draw, it's right up against your Y-axis, but make sure it doesn't ever actually cross the Y-axis. If your line curves and goes above the X-axis, you've graphed it wrong. Okay, it's running along the X-axis. So when I'm trying to find the domain and the range, let's talk about domain. Domain is is what values? X or Y?
X.
Domain is my X values. So if I'm looking at this graph, there's an arrow on each end. Is there anything that X cannot be? If my lines go off in both directions forever and ever, is there anything X can't be? No. So what is my domain? All real numbers. Perfect. It's always that pesky range. Range is where we have to really focus and try to figure out what's going on. Range has to do with our Y values. And again, if we're looking at where that graph runs, what Y value, what imaginary horizontal line does it never cross? Okay? Look at it right here. You see it right here? This line right here? It's running along which number on the Y-axis? 0, right? Does it ever go above 0, that line? No, so Y is greater than 0 or less than 0? Less than 0. So you're going to follow that line. What Y value? If I follow that line and go all the way over to the Y-axis, what line is it running along? Because that's my value. And then I got to decide, are all my Y values greater than that number or less than that number? All right, let's do another one. Go ahead and plug letter B into Desmos. And remember, a fraction, when you're in the parentheses, if you do 1 divided by, it'll give you the fraction bar. And then again, hit that A raised to the power of B button so that you can put in the X. Give me the Y-intercept again. Kayla? You don't have Desmos? Okay. Carson, what's the Y-intercept?
2.
Positive 2?
Yes.
All right, so right here we've got a positive 2. I need one more point. Xander, can you give me one more point on the line?
Yes, ma'am.
Where is it? So a second point, -1, we go left to -1, and we go up to 8. Now, be very careful. Again, as you draw this function, it runs along the x-axis, never actually crossing over it. Okay, so be very careful. It might even lay on top of it a little bit, but it never actually goes under it. So make sure you're very, very careful. Now, again, my domain. What's my domain going to be? Okay, there's nothing that my x value can't be. So my domain is all real numbers. But we got to figure out that range. All right, we know it's y. And our graph this time runs along which y value? If I run my finger along the graph and I go over until I'm hitting the y-axis, again, what y value is it running along? 0. Again, it's 0. But are my y values in this graph getting larger than y, or are they getting smaller than y? Larger. So y is greater than 0. Okay, y is greater than 0. Now, you got one more. Okay, and these were my graphs on these are what they look like on my Desmos. Okay, but you guys did a great job giving me all my information. So, do letter C. Now, this actually, we're not going to get into this today, but this function actually has a transformation that's been done to it. All right, you notice how at the end they added 2? Does anybody remember? And if you remember, raise your hand so not everybody's yelling at me. But if they've added 2 to the end of the function, is that a translation? Is that an up, down, right, or left movement? Is that a reflection? Did they reflect it over an axis? Or is that a shrink or a stretch? Does anybody remember? Avery?
Translation.
That is a translation. Do you remember if that is an up or down translation or a right or left translation? They've added it to the end of the function. So that is an up or down. In this case, it would be up. So you're going to notice as you put it into Desmos, it's not running along the x-axis anymore. What y value now is it running along? Does anybody see it? 2. Very good. So that's going to change our range just a little bit. Now, I need to know the y-intercept. Somebody tell me the y-intercept.
0, 6.
Okay, we got 6. And then I need one more point. Deslin, can you give me one more point? So if we go right to 1 and we go up to 10, we've got a 1, 10. Now, be very careful because we've got to find the imaginary horizontal line that this graph is running along. Okay? Because we don't have the axis this time, but we do have, if you look, we do have it running right along that 2. So that's where you want it. Again, make sure it does not cross over, cross under. But it's running along that imaginary horizontal line through 2 on the y-axis. So, again, what would my domain be? All real numbers. There is nothing. My lines keep going in both directions. All right, my range. Now be careful. We know it's y. But this time it's running along what y value? 2. And are all my y values larger than 2 or are they smaller than 2? Larger. So y is greater than 2. Okay? So can you see the difference? If I were to lay in front of you a graph that has a straight line on it and a graph that has this rounded boomerang looking graph, you should be able to tell me the line is linear functions. The boomerang rounded graph is an exponential function, okay? And you're going to see more exponential functions in tonight's. We're talking about exponential decay and exponential growth problems. So you're going to see more of these graphs, so you'll learn it even better. But make sure you understand, if you end up with a straight line, you have done something wrong, all right? That is lesson 6.3.